hopefully we are live. Just checking. Let's see if this thing works. Cool. We're up and running. Hope you are doing well today. Going to be going over DFU on with MCUBoot. Specifically, going to be talking about using the two schemes. We're going to be doing a secondary partition within the device itself. So most devices have built-in non-volatile flash. And then we'll also be doing just setting up an external flash as well for that same purpose. So, and I'll get into the details shortly. But if you haven't already, please subscribe. Leave me a message. Hit that bell icon, like button, whatever you feel like. But I really appreciate all the feedback that you guys provide for me for these live sessions, because without your feedback, I just kind of pick and choose what I want to do. But when someone has a topic like this one and they're like, how do I do this? I can create some new content, and here we are. Also, to go without saying, my heart aches for the people in Ukraine. I'm sending my support and prayers. I have know some people out there so it's just really tough time. So just thinking about them, sending support, that's all I have to say. Beyond that, let's get going. So, what I'm going to first do is a couple weeks ago, was it last week? I don't even remember. Everything mushes together. But one thing that came up was over the week, one of the listeners or watchers, Tim, he sent me a message here on YouTube and also on GitHub. And he was like, "How do I tag or set the version number in MCUBoot?" So what you can do, how it works is you can set the version number when you're signing an image, and that allows MCUBoot to make sure that the image that's being downloaded and updated is newer than the one that's already on the device. The cool thing is all you have to do is just add one line to your CNIC list. So deep inside the Ninja script that actually gets compiled to actually build an app in Zephyr, you can see the default is 0.0.0 plus 0, which is like the commit number. And what we want is that we want that to reflect the actual Git tag that we're using to tag the version of the application. So you can see where all these variables came from. It was all that crazy regex that we talked about before. If you haven't watched it, I should put a link in the description box describing the previous live session that we did on this, so it won't be like completely new. But the idea is that we got all these version variables, and then we're reusing them in the config _ MCUBoot _ image _ version, and that is the config variable for setting the version number, which will get populated in that Ninja script. So if we go back and we run the build again, you can see that it got populated in this case. So this was actually, I took this off of a running example just to make sure it was working okay. So the documentation states, and I haven't tested it, but I'm assuming why they have this version number is to make sure, like I said, that whenever you do an update, you want to make sure you have a newer version than the one that's already on the device. So according to documentation, that's what it says. It'll allow an update from 1.1 it'll allow an update from 1.0.1 to 1.1, but you can't go the other way. And one thing I would say is, if you're doing a lot of like local updates and local debugging and local development, you might want to turn this off. Mostly because then MCUBoot will not update an image with the same version number. Again, I haven't tested this, but if you find yourself, you put that code in there in your application, you got it working, you're like, it's not taking my update. I don't know what's going on. You might just have to uncomment it and then make sure that, or set it a variable, like if you're doing a production versus debug or development, you can turn it on, turn it off depending on what you have set up. So nice thing is with Zephyr, you have some freedom, just create some conditional statements inside your CMake list to make it do what you want. So onto the show for the main part here related. So this is all related to MCUBoot, but we're going to jump into how to get working on internal flash. We're going to talk about loading it. I know many of you are already aware of how to do that, so I'm going to gloss over it, but it's there. And I actually did a talk for Zephyr developer conference last year on MCUBoot. So it's going to be kind of some of the same content, just a little bit different. And then I'm also enabling MCUBoot for use of external flash. So primary on the device, and then over SPI or quad SPI to an external flash that we're using as a secondary to load. And you'll see what I mean in a second. Gotta rock that T first. Last week I had a slide with one line. This week I have another slide with one line. Literally to turn on an MCUBoot for any project is this one line. So, I'll zoom in here. Let's get this out of the way. So we're going to enable building the bootloader. We're going to merge it. So what happens when you actually enable this? Because there's a lot of magic that happens on the back end that you don't see. So this is why I made this slide. It's just like, what are all the things that are happening? We're building the bootloader. We're also building the application. We're merging the application. We're signing the image, and then by default, when you turn this on, it's going to default to a single or a dual slot configuration within the device. So you don't have to do anything extra. And as long as your device and processor is one supported in Zephyr, you're good to go. And then once enabled, there are some options. I believe you can do it also over USB. I didn't put it in there because I'm pretty sure you can do MCUBoot over USB, but you got UART, and then you got OTA, so we're doing firmware over the air, like Nordic has their firmware over the air download client combination that they use. The tools that we use for this MCU Manager / the custom version of Newt Manager that I had developed for the NRF9160 Feather, it's basically one and the same. And remember, when you build an application with the MCUBoot turned on, it will build the update binary, and that guy is located in that build folder, Zephyr app_update.bin. So that is the important one. If you want to do any over-the-air updates or anything like that, that is the signed and ready-to-roll image that you can send to your device over UART using MCU Manager or over the air with whatever OTA setup you want to use. So they both work. And this is just a new manager transferring an image over serial. Should look fairly similar for anybody that, and this will look the same if you're using MCUBoot or MCU Manager as well. So that was pretty straightforward. Here's the complicated part of if you have an image that is very large that you wouldn't be able to put, so when you have two partitions on your internal flash, you're basically cutting your flash space in half. So what can you do to get some more flash space, especially if you have some hefty applications, is that you can use an external flash to do that, all the load, or handle that secondary partition, so your first partition can be much larger. And that's the idea of what we're doing here. And so we'll dive into it, but it just allows you to use bigger images. And the biggest thing that I've seen so far is most of the work I've done, I've never really had to worry about that. I've never really had to use an external flash for secondary or anything like that. But there's one technology that for OpenThread / Matter, if you're using Matter is huge. Matter takes up a ton of space, and in most cases, you're going to have to use an external secondary update partition for that guy, because they're just, the update images are just so huge. So there's something to keep in mind if you do start playing with those technologies, because I was talking about it the other day, and it's just like, how do we, this doesn't, like, it takes up so much space. But that is a topic for another day. Turning it on. So for Nordic parts, Nordic tried to make this as easy as possible, and man, I really need that tea today. All right, so for the NR52 840 DK, I'm actually, this is what it's for. So we're setting the external flash as the partition manager external flash device, and that's doing a bunch of stuff on the back end to basically select that device and use it as the external, as the secondary partition. And then I should go back and actually zoom in. You can see this one, but you won't be able to see this one. And the biggest thing for so for NCS 1.7, they do have some other things you need to set up. It's mostly just the partition size for the external device. You just got to make sure it matches. This goes away in NCS 1.8, and it never existed in 1.6. So depending on where you are in the NCS ladder, it'll be different. I tried to include some links down below, depending on what NCS you're using, or if you're not using NCS, I will go over vanilla Zephyr as well. So we'll cover that at the end. So you're going to be putting in a child image. There should be child image / MCUBoot, I believe, / purej.conf. And we're just entering that, the secondary. That's probably the most important part, depending on what you're doing. If you want it to be transferring over serial or whatever transport layer, you're going to have to turn things on and off. In this case, we're using serial for this particular example. Config_flash is on. We need that guy always. The partition, and then the partition size MCUBoot, I believe that would just be the primary partition size. But those are kind of some of the safe defaults, and again, just setting the values here in your project configuration, just turning on MCUBoot, and also just matching that secondary setup, that size setup. Like I mentioned, it's only for 1.7, and newer versions, it's unnecessary according to some of the dev zone things that I've seen. I looked it up earlier, and they're like, yeah, in 1.7, it's kind of weird. 1.8, you just kind of turn things on and they work. So looking forward to up-revving everything to 1.8 or even 1.9, because that just came out recently. But this is great, but it's like, okay, what if you don't have a board that's not a Nordic board? So I decided to put this in here because this is like Zephyr in general. You can do it. Supposedly you can do it just with vanilla Zephyr. I kind of looked into it. I didn't have enough time to actually build it on this board here, but should work as I show in the next slide. So we'll just jump there. The way they set up so traditionally the way the partitions are set up, they're set up in your board file, your board definition. And what we're doing in this overlay is we're kind of reassigning some of the variables for the partitions and setting them to the external device. So that MX25R64, that is the quad SPI that's already defined in the default board definition. So we're removing the slot 0 and 1 partitions, scratch partitions, boot partitions, and then kind of replacing them in the partition table, so they are in different places. So you can see boot partitions, that's where the bootloader is going to live, and then the slot 0 is where the original application is going to live, and that's the space that when you are copying from the secondary on the external, you're just going to be copying over that partition in place. Of course, there are some checks done to make sure that that image is valid before that happens, because it would not be good if you transferred from the secondary external into the primary and overwrote with some bogus app. So that's the important part those are the important things that MCUBoot does to make sure that that image is valid before before it gets transferred over. And then and then on the right side there you can see slot 1 partition, and we're setting that slot 1. And you can see also slot 0 and slot 1 are the same size, and that's very important. You want to make sure that both slots are the same size. Otherwise, you might get some compile errors, or for the secondary, it might be possible that you can compile when they're 2 different ones, but if you have an image that's bigger than that size, it might get angry at you. So something to keep in mind. And so for the vanilla Zephyr configuration setting, you can have a MCUBoot specific config file. Again, you can put it in that child image folder under MCUBoot, or I think you can just create an MCUBoot conf. Zephyr looks for both of those things. And then depending on the configuration you have, either if you're using SPI, you're going to be indicating SPI NOR, or for instance, Nordic has their quad SPI interface, so you're going to be replacing that SPI stuff with the QSPI definitions. So either or, you can do it with both, I believe, which is handy. And then, so that's pretty much it. I know there aren't any questions, but we're just going to summarize. MCUBoot gives you the option to basically load new updates from a built-in secondary partition. And what it does there is that you're loading a new image, and if it's set up, I believe it does it in this case for the built-in partition, but it's called XIP, or execute in place, where it'll just switch whichever partition is active, so you don't have to copy stuff back and forth. So you get an OTA update, or you get an MCUBoot or MCU manager, and you're transferring it over. It's going to go to one of those partitions, whichever one's not active, and then it's going to check it, and then it's going to switch it over. It's going to reboot, switch it over, and then boot into that partition to make it work. Or if you want to maximize as much built-in flash space that you have, you can do the external secondary. So you have your primary partition that's slot 0, and then you have on your external quad SPI or SPI flash, you have your slot 1. And whenever you're downloading or transferring from MCU Manager or over the air, it's going to go to the secondary, and then you reboot, and your bootloader checks that image and sees if it's valid. If it's valid, it's going to copy it over to your device. The device is going to boot up, and you're going to be in your new image. So it uses the same tools, nothing changes, which is nice, and it's kind of like out of the box batteries with like Nordic's SDK and some of the more finicky things you have to do in vanilla Zephyr versus what you need to do with Nordic, where they kind of take they do some of the harder stuff for you. So hopefully that all made sense. Let's see. I do have a question here, and so Solius, I butchered that name. Sorry. Do NOR flash work with the same SPI bus as SD card? In Zephyr, they actually have some pretty good support for SD cards, and you should be able to use a SPI bus with an SD card, which is very handy. I've done it in the past. So. And if you, or even better yet, if you have like an SD card, some chips actually have an SD interface that is dedicated. I think the ESP32 chips might have one, but yeah, you should be able to. I haven't played, so I played with using FATFS for that guy, but I haven't done any, like for this particular topic. I have not done any secondary booting from, secondary transfer from a SD card onto a primary. So you might have to play with that yourself and see if you're able to do it. I would try to I would try to err on the side of using an internal part instead of an external part, because you have all those spring connections for the SD cards, unless you're like literally soldering it to the board, which is usually not common. So using an onboard, flash chip that you actually solder down, much preferred as a secondary versus a SD card. Wasn't sure if you were going there in your question, but hopefully that helps. But yeah, that's it. And I'm gonna adjourn here because we gotta get back to work. But if you have any questions, leave them in the chat. Give it a thumbs up, and send me a message if you have any questions. Things that you want to see me cover. I'm gonna be here next week, of course. And there's always the Zephyr. There's a whole bunch of stuff that I could cover. So I work on your suggestions. Really appreciate you coming out today and joining me. And see you in the next one.